Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook. This one question lost more marks than any other on last year's papers. A simple area calculation where students treated 3.2 centimetres as exact and lost full marks. Sound familiar? If you've ever written down a rounded value and trusted it without thinking, this episode is for you.
Oh, that's me. I remember thinking 3.2 means 3.2, and then the answer was off. It felt like a tiny detail, but it cost me marks.
Exactly. That tiny detail is the whole point. Rounded numbers hide a small range of possible true values. Today we'll make that range your friend. By the end, you'll have a habit that prevents those avoidable mistakes. The concept, what bounds actually mean. Start simple. When a question gives a measurement like 3.2 centimetres to 1 decimal place, the real length could be slightly smaller or slightly larger. In exam language, we call these the lower bound and the upper bound. So 3.2 isn't exact. I always thought that a number with 1 decimal was the exact measurement the question wanted. Common misconception. With 3.2 to 1 decimal place, the true value could be anywhere between 3.15 and 3.25, where 3.15 is included and 3.25 is excluded. We write that as an inequality. 3.15 is less than or equal to x, less than 3.25. That little less than or equal to and less than notation is what examiners expect.
Why those numbers? Because rounding to 1 decimal means any true value in that half-unit interval would round to 3.2. For 2 decimal places, it's the same idea but with 1/100th increments. For example, 3.21 to 2 decimals means 3.205 is less than or equal to x is less than or equal to 3.215.
That makes sense when you say it like that. But how do we use it in a question? Say, area of a rectangle. Great question. Let's walk through a rectangular area example step by step. Suppose the length is 4.6 metres to 1 decimal place and the width is 2.1 metres to 1 decimal place. The area formula is length times width. First, write the bounds for each measurement. For length, 4.55 less than or equal to L less than or equal to 4.65. For width, 2.05 less than or equal to W less than or equal to 2.15. Write these down. This is M1 territory. Correct bounds written as inequalities. Next step. To find the minimum area, you multiply the smallest possible length by the smallest possible width. So L min times W min equals 4.55 times 2.05. To find the maximum area, you multiply the largest possible length by the largest possible width. But be careful. The upper bounds are exclusive, so you use 4.65 and 2.15 conceptually, but when multiplying for a maximum, you consider values approaching those upper bounds. Practically, in exams, you'll see the maximum area written as 4.65 times 2.15, or you can show the inequality and explain area less than 4.65 times 2.15.
Exactly. You show the working. 4.55 multiplied by 2.05 is less than or equal to A, less than or equal to 4.65 multiplied by 2.15. Then compute both sides. If the question asks for bounds, leave the answer as an inequality with appropriate rounding only when asked. If it asks for the maximum possible area to the nearest whole number, you follow that instruction after establishing the bounds.
Important mathematical reason. Bounds capture the set of all possible true values. Writing the inequalities is not just notation. It demonstrates you understand what rounding means, and that is where method marks live. The exam technique, how marks are awarded. In a typical bounds question, you'll see 3 marks available. M1 for writing correct bounds for the given measurements,
M1 for applying those bounds in the formula, for example, setting up 4.55 times 2.05 less than or equal to A less than or equal to 4.65 times 2.15, and A1 for the correct final inequality, or value if the question asks for a specific rounded answer.
So, even if I can't finish the multiplication, I can still get marks if I show the bounds and substitution?
Exactly. Write down the bounds and the substituted inequality. That's at least 2 marks. Examiners mark the method, not just the final number. So, write it down, don't just think it, is crucial. Common mistakes that lose marks. 1. Using the rounded numbers directly without bounds. 2. Forgetting the exclusive upper bound, writing equals to instead of less than for upper limits. 3. Multiplying a lower with an upper incorrectly when finding min or max. Avoid these by stating clearly which bounds you're using for min and max. Also watch units. If length is in centimetres and area in centimetres squared, keep the units consistent and state them. Examiners reward clear units and method notes. The quick win, a 30-second checklist you can use in every question. Ready? Memorize these 3 steps. 1. Write lower and upper bounds for each measurement using the correct half-unit rule. 2. Substitute bounds into the formula clearly, showing which bounds give minimum and which give maximum. 3. State your final inequality, or value, with units, and if asked, round only after establishing bounds.
That's brilliant. Any memory trick to remember that order?
Yes. Use the phrase bounds, substitute, state, BSS. Say it once before you start the working, and the examiner will see your logic even if you run out of time. Let that sink in. Worked example under timed conditions. Question. A rectangular tile has length 4.6 centimetres and width 2.1 centimetres, both to 1 decimal place. Find the bounds for the area. Step 1. Bounds for measurements. 4.55 less than or equal to L less than or equal to 4.65, and 2.05 less than or equal to W less than or equal to 2.15. Step 2. Substitute. 4.55 times 2.05 less than or equal to A less than or equal to 4.65 times 2.15. That's M1 for bounds, M1 for substitution. Step 3. Multiply both sides. Compute the left. 4.55 multiplied by 2.05 equals 9.3275. Compute the right. 4.65 multiplied by 2.15 equals 9.9975. So write 9.3275 less than or equal to A less than or equal to 9.9975 centimetres squared. If the question asks for the bounds to 3 significant figures, you'd give 9.33 less than or equal to A less than or equal to 10.0 centimetres squared. Note the upper bound becomes 10.0 because of rounding. Show the unrounded inequality first, then round if requested. When you rounded the upper bound to 10.0, that looks like the area could be 10, but the original inequality said less than 9.9975. Do we need to explain that? Good point. If you round the ends, keep the inequality sense correct. A rounded upper bound of 10.0 should be written with less, as in 9.33 less than A less than 10.0 centimetres squared. If the exam wants the maximum possible value, then you might be asked for the largest integer less than the upper bound, so always read the question carefully. One more examiner tip. If you show both the substituted inequality and the computed numbers, examiners can award M marks even when arithmetic is messy. So always show the substitution step before you do the multiplication. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and a downloadable bounds checklist at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.